Hello friends, welcome to Live Mathematics. Today we are going to discuss row echelon form of a matrix and reduced row echelon form of a matrix in the same video. Okay, so stay till the end. Let us start. What is row echelon form? Now first says the conditions are all rows consisting of zeros are at the bottom. So the zero rows should be at the bottom of a matrix. So this is like this. If the matrix looks like this, then the zero rows will be at the bottom. So here will be zero rows, not at the top. A zero row cannot stay at the top. Okay, so the zero rows will be at the bottom, and the leading coefficient, which is also called pivot of a non-zero row, is always strictly to the right. This is important, strictly to the right of the leading coefficient of the row above it. So the above two conditions imply that all entries in a column below a leading coefficient are always zeros. So let us take some example. So suppose this is a matrix. So 1 1 1, okay, 2, then 0 1 0 0 0 0 0 0. Okay, so let us take the first. So let us check the conditions. All rows consisting of zeros are at the bottom. Look, the zero row, this is the zero row, this is at the bottom. Then the leading coefficient. What are the leading coefficient? The first non-zero element of every row is the leading coefficient. So this is the first non-zero element of the first row. This is the first non-zero element of the second row. Okay, so these two are the pivot or leading coefficient of a non-zero row is always strictly to the right of the leading coefficient of the row above it. Okay, so this is the first row and this is the second row. In this row, look, the row above it is this row, and the leading coefficient in this row is this, and the leading coefficient in the next row is this, and this leading coefficient is strictly right to this leading coefficient. This leading coefficient is strictly right to this leading coefficient. Okay, so actually if you want to understand the second condition better, just write this matrix 0 1 0 0 1 1 1 2 and 0 0 0 0. Look, this satisfies the first condition, that is zero rows is the bottom, zero rows stays at the bottom. So this is the zero row, and the leading coefficient of the first row is this, leading coefficient of the second row is this, but the leading coefficient of the second row stays left side. In the left side, look, in this side. Okay, so stays in the left side, so in this side. Okay, so stays in the left side, so in this side. So this does not satisfy the second condition, because the second condition says the pivot must be strictly to the right of the leading coefficient. Look, leading coefficient of the row above it. So this leading coefficient is strictly to the right of the row above it, of the leading coefficient of the row above it. So this is a row canonical form, this is a row echelon form, and this is not a row echelon form, because the leading coefficient of the second row stays at the left side of the leading coefficient of the first row. Okay, now the general form of this type of matrix is this. I am giving an example of a 3 by 5 case. So suppose 1 A0 A1 A2 A3, this is the matrix. Okay, now suppose 0 0 2 A4 A5. Okay, then 0 0 0 1 A6. Okay, so look, this is the leading coefficient of the first row, and the leading coefficient, this is the leading coefficient of the second row, this is the leading coefficient of the third row, and the leading coefficient of the second row stays right to this. So this leading coefficient is at the right side of the above leading coefficient, and this leading coefficient is at the right side of the above leading coefficient. So all the pivot stays in the right side of the previous pivot. So this pivot stays at the right side of this pivot, this pivot stays at the right side of this pivot. So this is the basic condition. Look here, this implication is also important. All entries in a column below a leading coefficient are 0. Look, this is a column and this is the leading coefficient, so all entries below this is 0. This is the leading coefficient, all entries below this is 0. So this is the general form how a row echelon matrix looks like. This is the general form. Okay, now we will go for reduced row echelon form. Okay, look the conditions here. It is in row echelon form. Okay, so the reduced row echelon form is, the first condition says it is in row echelon form, and the second condition says each column containing a leading 0 is in all its other entries contains 1. So first condition is it is a row echelon form. Second condition, each column containing a leading 1 has zeros in all its other entries. Okay, so let us look by example. First, it is row echelon form. So suppose let us take a matrix in row echelon form. So let us take the previous example, that is 1 1 1 2 0 1 0 0 and 0 0 0 0. This was our previous example. So this is a row echelon matrix. Okay, we have to make it reduced row echelon form. So the first condition is satisfied. Now next condition says each column containing a leading 1. So this is the leading 1, this is the a leading 1. So each column containing a leading 1 has zeros in all its other entries. Look, this column contains a leading 1 and contains 0 in all its other entries. And look at this column. This is the leading 1 and contains all other entries. It should have contained 0, but this entry is 1. So to make it reduced row echelon form, this entry we have to make this entry 0. Okay, now look, this is a pivot or leading 1, and the all other entries in this column are, this is 0 and this is 0. So this matrix now becomes reduced row echelon form. Okay, so now we will show you the general form of a reduced row echelon matrix. Look, we are showing and giving an example for a 3 by 5 case. So 1 0 a1 0 b1 0 1 a2 0 b2 0 0 0 1 b3. Look, first of all, this is in row echelon form, obviously. Now next, this is the leading 1 and all entries in this column are 0. This is a leading 1 and all entries other than this leading 1 are 0. And this is a leading 1, all entries other than this are 0. And this is row echelon form because every leading 1 contains at the right side of the previous one. Look, this leading 1 is at the right side of this leading 1 is at the right side of this. Okay, so this is in row echelon form, obviously, and also in reduced row echelon form. And this is the general form. Which column will contain leading 1? In that column all other entries will be 0 and the leading 1 will be at the right side of the previous leading 1. So these two are the basic conditions. So hope friends you have enjoyed the video. Please subscribe the channel and don't forget to share the video with your friends and tap the bell icon. Stay tuned with us because we will come back shortly with this kind of video again. Have a nice day. Thank you.